Hey guys, this is Absolute 5 here. So we are back again today with another math concept, and we're combining the power rule with the chain rule. So what do I mean by that? I mean you can actually link two derivatives in one combo. It's pretty cool actually, and also you have to be aware of this when the situation arises. And there's other techniques that can happen too, where you can have, a power with product rule, maybe power quotient, depends on the situation. But in this specific case, we're combining the derivative of the power rule with the chain rule. So let's define that situation. What does it mean to have that situation? If n is any real number and u equals g of x is differentiable. I think they meant y, not u. Differentiable. It's like the best y you've ever seen. Then dx parentheses g of x n. So you see how you have two functions, right? That you have a power rule, but then you also have to do the derivative of the inner function. So when I do the derivative of the power rule, we know that we have to bring the n in front of this function here. But what we learned recently about the chain rule is, remember, it's 2 and 1. So do the outer, but that's being multiplied by the derivative of the inner. See that? That's the idea of combining two derivatives, where you have the outer function here, which is there, the power rule, and then you have the inner function, which could be whatever it could have been. It could have been a product rule, it could have been a quotient rule, even, depending on whatever the situation is. So let's do an example, see what it's like to apply this. So let's say I have y equals x to the third minus, let me just lower it just a little bit, just so the camera can see it. Example, y equals x to the third minus 1 raised to the 100th power. Now, it is impossible to write out this 100 times, because ain't nobody got time for that. Like, really, nobody got time for that. So when I do the derivative of y, so it's dy over dx of dx of this function, right? So I'm going to do the power rule first. So what do? Based on the power rule, I bring this number to the front and subtract it by 1, so I have 99. Then I have to multiply by the derivative of the inner function. What's the derivative of x to the third? That's going to be 3x squared. And there's no 1 because there's no constant. Well, constant has 0 slope. That's why they're not there. So now, by the power vested in the law of commutativity, when I say that the law of the commutative property law, you're able to multiply in any order, whichever way you want. So you can multiply 100 by 3x squared, 3x times 100, it doesn't matter. Order does not matter because the operation is multiplication. So because of that, 3 times 100 is obviously 300. X squared times x to the third minus 1 raised to the 99th power. So ideally, that's the idea what you want to do when you take the derivative. You want to practice these rules as you go along. It's a bit tricky, especially when we get to like product chain rule. Those are hard, and also with when you have to do the chain rule product with cosine and sine, or sine or cosine. Those get a little bit tricky, but we'll get to those in a later date. Okay. So that's the lesson for you guys today. This has been Absolute 5. I'm Roger Palomino. Mash that like button and subscribe button. And if you like my content, be sure to also smack that bell button. So this way we get more content going here, okay? Don't worry, don't smack it. You might break it. Then you have to get another computer or phone. Okay, so that's the lesson for you guys. I hope you enjoyed it. I will see you guys tomorrow with another lesson. So remember, math is infinite because there are infinitely many possibilities. You can make anything happen anytime today, okay? So take care.